Hey there. So I decided to make this video in order to give you a better idea of how you can collaborate with IDW and how we can work with you. So the first thing is that the product development process, we divided it into three different steps. It's the natural process that it follows. So we start with product validation, then we do the product development, and finally we jump into mass production. Now, product validation, we can split it into 5 different sub-stages. The first one is the product viability assessment. This one is the most important one by far. It's where we actually determine whether or not the idea is valid and we should pursue it, or if maybe we need to pivot or actually kill the idea. Then we do concept optimization, which is where we actually give it a shape and we define features. We make it less abstract, let's say. Functional validation is a optional stage. It's required in some projects where there's like very fundamental questions that just cannot be solved through ideation, for example, and normal research. And that requires building prototypes. Then we have high level design, which is when you basically design the detailed architecture around the product. For example, what type of APIs or libraries you're going to use for the software, what type of network topology we're going to use, critical components that we're going to be using for the electronics as well, and flow diagrams or general flow diagrams, and business process modeling notation if required to express the flow of the firmware and the interactions between the user, etc. And then we have the custom manufacturing forecast. Together with this, we can actually determine if the product is going to meet the requirements. So initially we do this just to validate the idea. We turn that idea into a concept. Once we have that, we actually turn that into a high-level design, and we estimate if this is going to be technically viable and financially viable. Then we do product development, which is where you do the raw engineering work. You fix all the details, make sure it's manufacturable, make sure it's going to work. You program all the code, you do all the integrations with libraries, and you do all the prototypes. And eventually you make some demo prototypes if required, or just the design for manufactured prototypes. And from there you build what's called bit packages. Bit packages are packages of files that are split based on the strategy that's necessary, so that we can reach out to suppliers. Another thing that you have to do is you have to handle IP properly, so you need to make all the different bidders sign some agreements, of course, because most of this is going to happen in China. And then you get quotations from them and you analyze it, you choose the right one, and from there you go into mass production. So in mass production, sorry, I actually skipped a little bit. In mass production, you expand your supplier research. Usually by this time, we've already done some research, or we already have some suppliers who are natural bidders for this, but we expand our research to find more optimal options if possible, and have them build golden samples. With those golden samples of your product, then we do what's called compliance lab testing to make sure that it meets all the requirements, all the legal requirements to be sold in the desired market. So this could be FCC, or it could be IP or ingress protection, or it could be UL or ROHS, or there's many compliance requirements. There's some that are necessary for transportation of lithium batteries, for example, etc., etc. And finally, we get to the production of the first batch and to the fulfillment or the shipping of that batch to our fulfillment warehouse, which is where IDW's work finishes. Now, I'm going to get a little deeper into the first stage. So the first stage, which is product validation, we have the product viability assessment, where you start with a general product idea, which is very abstract. Then from there we turn that into a go or no go decision with clear next steps. And the great benefit that this gives you is you avoid wasting money on ideas that don't work commercially or technically. And the main deliverable is the product viability assessment report. Now, this is really important, and I will go a little bit deeper into one of the different tools that we use for that. I'm not gonna share everything here because it would be a very long video, but this is really important because in our experience, people who have skipped this end up making changes in the concept level later down the road when we already start doing engineering work, because they realized that there was either a competitor or a patent or that they weren't aware of, or maybe they realized that their idea is just not that attractive to their end users. So what we believe is you should build what's called gate processes. So this would be the gate number one. The first is, should we pursue this idea? If the result is yes, then excellent. Let's move it into the concept. Then we optimize the concept. And once we lock down the concept, once this gate is closed, you don't go back to that because it's expensive. Then we go into functional validation. So functional validation lets us know if it's something that we can achieve and if our fundamental questions can be answered through proof of concept prototypes or other means. If we pass this, then we move to the next stage, which is high level design. And from here, everything is fairly straightforward. So most of the risk in your project, it's most likely going to be here in these three stages here. In the product viability, or in the idea stage, in the concept stage, and in the proof of concept. Basically, it's in the idea and in the concept. That's where all the risk lies. So we want to gate those, and we don't want to avoid them to avoid spending money on the wrong idea or concept. Now, and moving to the next stage, I'm gonna give you a general idea of what a product. This is one of the parts of the product viability assessment, but it is really important because it creates a footprint for what the idea stands for, and it starts like asking who's the audience, like what's the core pain point that we're attacking, what's the underlying cause, what impact it has. So target market, then we start looking for a lot of evidence that backs our claims. So for example, if you're trying to create something that you believe, or you have this idea of a product that you believe that's going to pacify babies through sounds, and we know that we have this intuitive idea, or you have this notion that that's the case, so you want to create a product around it, but we need to know what type of sounds and what's the evidence behind that. Is that a pattern? Is that a particular frequency? Is that a voice? So how do we create that effect? How can we make sure that we're getting the effect and the phenomena that we're trying to use, so that we can actually create it, right? So that's why we recommend getting evidence sources. Filling this out nowadays, it's a lot easier with the help of AI. Now we need to define a persona. It includes the age, gender, etc., etc. We need to understand in which context they're going to be using it. Is it the mom that's going to use it? Is it the dad, or both? Are they going to use it in the morning, at night, anytime? Is this something that needs to be used in a recurring basis to create the effect, or can it be used one day or the next, or maybe no? after 2 weeks it can still have the same effect. And what is the negative consequence of the problem of the target audience? That's another thing. Then we do a big, very detailed research on competition. And we don't just go into Amazon to look for them. We go into AliExpress, Google, Patents, Indiegogo, Kickstarter. Because who knows, maybe there's someone who's already started developing something like that and you're not aware of it. So you have to look for all the different sources of competitors. Then we start doing the use cases. That's something that is usually done with different diagram software. But it basically explains like what are the different scenarios where the user interacts with the device. So we go from like when they open it, like how should the experience be like, and is it a mom that's going to be using it? Is she stressed? So she's not going to have a lot of time to figure out and read a booklet. So is this something that needs to be installed or deployed, or does it have to be stored, or is it always on display? Where is it stored? Is it exposed to weather? That's what the use cases are really important for. Do you leave it connected, or do you work like in a portable mode and then on a stationary mode, or is it only stationary? That's kind of like the use for this. This is extremely important because it helps us define the features of the product. Then we go for different types of requirements as well to help define it even further. We come up with mock-ups of the idea. This can be made very easily with the help of AI, or some hand doodling as well is really valid. And then we start looking for the different types of features that are unique, that nobody else has. We call those the delighters, and there's a framework for that called Kano. And we start defining the core attributes, functionalities, or features that the product needs to have in order to be what it has to be. And then we go into the concept optimization. Now in the concept optimization, basically we make drawings and we start defining how it has to be assembled, how many parts, what materials, what is the different components that it needs to have in order for it to be what it's supposed to be, right? Then this is an optional stage, as I mentioned earlier, the functional validation. This is an example of a proof of concept prototype that we made for a product where we're actually having a lot of fun. We were creating this hair braiding device, and before we added any motors, we just created this manual jig, and we actually tested it with the hair of someone from our team, and we were effectively able to braid the hair, and thus we validated that the mechanism that we designed was functional. We were laughing really hard. Now, the other stage that follows after that, if we need to do that, if not, the one that follows after the concept optimization is the high-level design. Now, the high-level design is more regarding the electronics. We do what's the critical component selection, then we do block diagrams, we do flow diagrams, and so on and so on. And eventually we do a custom manufacturing forecast, which gives us an idea of what the unit cost is going to be for the product, depending on what the volume is going to be. And we actually create a bill of materials for the electronic components and all the different components as well. We can quote them or estimate them if we have something that's extremely similar. And we can also estimate the cost of the tooling, etc., etc. So that is really important for you to have a business case that you can present to investors, and also make your own decisions on whether or not it's viable to do the project or how you're going to do it. Now, After that, we finish what's stage 1 and we move into stage 2, which is the product development. And here I'm just showing some images of what the work looks like for example, doing schematic diagrams and then turning that into PCBs and actually assembling them and seeing that they work, and also like what it looks like when we do the PCB tracing. Then when we build some prototypes in-house, and eventually those prototypes turn into something that our customer can actually interact with, like this one, and they are functional, so they have all the functions that they need to have. I'll stop this here. And now that stage, once we have the functional prototypes and everything's being validated, we do what's called a bid package, which has usually a lot of different files. So it has like workshop drawings like this one and like this one, and it also has what's called the Gerber files for the electronics. It has a lot of files for the electronics. It has the hex files for the code and the firmware, etc., etc. The tables and the service tables for Bluetooth interaction with apps, etc., etc. Then another thing that's super important is that we use what's called a companion presentation where we share updates. So here you're gonna see that we have this for one project where we have all these slides, and in here we're just giving updates to our customers. So every week we share updates on all the different aspects of the product until it's finished. So that's something that we do that I think is very different. And finally, for production, we do something that also not a lot of people do, which is we actually go, we do support throughout the project. Like as the production is happening, we're sending files, we're in communication with the suppliers. We help with the quality control of the different parts. Here, for example, it's a process that we taught one of the suppliers how to do, and they were doing the testing to make sure that the behavior was properly made. And the other thing is we also, if necessary, I can also go to China, to the factory, to make sure everything comes out well and things work out, or meet other factories or bidders to see if we have better alternatives if prices start going up, which is something that happens. Anyways, I hope this has given you a clear idea of how IDW works. We're a small team, as I mentioned, and I'm Mauricio Villalobos. I am the lead industrial designer, and you're going to be interacting with me a lot. And I hope that this has convinced you to working with us, because I know that's going to be a really good decision. Anyways, thanks a lot for your time. Bye.